Okay, once again, we are only doing the challenging questions as far as preparing for the exam is concerned. So the basic type of questions, well, you'll find it in the recordings already. We've done these things, but now we only want to do the challenging questions. That's the whole point. So let's look at the first one. This one says we need to calculate a possible value for a squared plus b squared. That's actually a squared plus b squared there. If it is given that a and b are rational numbers such that square root a plus square root b will be equal to square root 9 plus square root 56. That is what they say. So we are given this. And from this which we are given, we need to find the value of a squared plus b squared. But we know the square root of a plus the square root of b gives us this answer on the right-hand side. So then, what is the first thing we need to do? The first thing we should do here is to square on both sides, because we don't want a and b to have square roots. We want a squared and b squared. All right. So let's square on both sides. So we take the square root of a, we add it to the square root of b, and we square this. Then we also square what is on the right-hand side. Well, this is what we say. Then the question is, what do we say after squaring on both sides? Now we need to use the FOIL method in order to expand the left-hand side. That's what we need to do. So after we successfully use the FOIL method, because we know that we have to take square root a and square it, and this will give us a. Then we have to take this one and multiply it with that one. Take this one and multiply it with that one as well. And that will give us 2 square root ab. And then lastly, we can take that and square it. And now we get b. Then on the right-hand side, the square root and the square, they will cancel out. So we are left with 9 plus square root 56. Well, in case you're wondering where the square root of AB came from, remember when we are using the FOIL method, we take this one and multiply it by itself, and we get A. Then we take this one and multiply it by that. Remember, you'll need to repeat the bracket twice. I'm just assuming that you are now comfortable with the FOIL method. Then you will get square root A times square root B here. And then this one times that. You'll get square root A times square root B as well. And then lastly, this one times itself, you will get a B. That's what I'm saying to you here. Then what? Well, every time we have square root A times square root B, this is the same as square root AB. And since we have 2 of them, that's the reason why you see me saying square root that here. That's the reason why. Okay, fine. Then the question is where to from this point? Because the question is asking us to find a possible value of a squared plus b squared. So what are we going to say from this point? Well, we can choose to square on both sides for the second time. The question is, what are we going to get after we square on both sides for the second time? And do we really need to square on both sides for the second time? Let's think about it. Let's carefully plan our next move here. And let's really plan that. So now we have 9 plus square root 56 here. Okay. Let's see. Let's see. We can be smart about this. Let's say we decide to group these two and say, let's take A and bring it closer to B there. Okay. And then, well, since we can see the square root here, let's try to see if there's a relationship between those two square roots. All right, let's try to do that. So this means A plus B must be taken and put as a group. And then here we have 2 square root AB. Then on the right-hand side, we are just going to have a 9 plus what? Let's go to the square root of 56 here. How can we rewrite the square root of 56? Let's see. Let's go to the calculator and say square root 56. We get 2 square root 14. Yes, that's how we can rewrite the square root of 56. In other words, we had to write it as 4 times 14. So it was 4 times 14 here. And then when we took the square root of 4, we got a 2. That's what we say. So we don't need to show them that it was 4 times square root 14. We can, in fact, 4 times 14. We can just say 2 square root 14 here. Okay, then what? Well, this is something we learned from Euclidean geometry. Well, it's not really from Euclidean geometry. It's a general concept that works every time. What is this general concept? In order for x plus y to be equal to a plus b, in order for these two things to be equal, that's if and only if x is equal to a and y equals b. All right? That's what I'm saying to you. Those two equations will be equal if their corresponding elements are equal to each other. So we are going to use a similar reasoning here and say a plus b will be equal to 9. In fact, we should be saying and here. Can you see that we have a 2 and a 2 there? So this means we can just say AB must be equal to 14. Because the 2 and the square root, they already have it in common. So we can just choose to ignore that and just say AB must be equal to 14. This is what we say. Then what? Now it's simultaneous equations here. Yes, it's really simultaneous equations. We can now we decide which equation to use here in order to express one variable in terms of the other and actually solve for A and then come back and solve for B. We can do that. But if you try to square on both sides here, well, it can work as well. Because as you are squaring on both sides, you're going to end up having AB somewhere there. Well, many ways to kill a cat. You just need to decide how you choose to approach it. Let's square on both sides. A plus B squared will be equal to 9. Oh, I need to square the 9 as well. So this is our 9 being squared. When we use the FOIL method and expand this, we just get A squared plus 2AB plus B squared, and this will be equal to 81. But then we know what is AB. We really know what is AB. But we tell them, but we know that AB is 14. This is what we know. Which means that if we can now take those two and group them together, the A squared and the B squared. So it means A squared plus B squared plus 2 into AB, which we now know as 14. Everything must be equal to 81. And so on. So now we can just take this one to the other side and then conclude and say A squared plus B squared must be equal to what? 81 minus 2 into 14. Well, this will give us 53. You could have done it by simultaneous equations from this point. The point where I'm putting 2 asterisks. Yes, you could have done it by simultaneous equations and maybe go to this one and solve for A and say A will be 14 over B. Then come back and substitute A into this equation so that you can have everything in terms of B only. Then solve for B, find the value of B, then find the value of A, and then square both of them. You could have done that. But there was no need because we know that when we square this, somewhere in that expansion, AB is going to come up. Now, this is the next challenging question. Now, they say to us here, it is given to us that f of x is defined as 3x minus 2 divided by x squared plus 10x plus 25. That is our function f. Now listen to the question. The question here is saying, determine the value or values of x for which the function is undefined. That is what they're saying. For which the function is undefined. That's what the question is saying. Now, the question is, what needs to happen in order for the function to be undefined? That's the keyword. In order for the function to be undefined, that's when the denominator is equal to 0. Well, the question is not really saying that. It's saying defined, Heben. Defined. It didn't say undefined. It said defined. Determine the value or values of x for which the function is defined. That's what the question originally said. Okay. So the keyword here is defined now. So what must happen in order for the function to be defined? Or at least, how do we find the values of x for which the function is defined? Now, this is how we can find them. Firstly, we need to find those values where the function is undefined. And then we can say it must be defined everywhere else. If we know that the function is undefined at 10, then it means it's defined everywhere. That is the concept. Okay, so that's the first thing we're going to do. We want to find the values of x for which the function is undefined. So we tell them the function is undefined when the denominator is equal to 0. That's what we need to tell them. All right? What am I saying? The function is undefined when the denominator is equal to 0. Right. Then we should solve for x here. So we factorize. What are factors of x squared? That's x and x. What are factors of 25 that add up to 10? It should be 5 and 5. And both of them must be positive. So this means that the function is going to be undefined when x is negative 5. Now that we know the function is undefined when x is negative 5, then where is it defined? Well, f of x is defined everywhere, just not when x is negative 5. So you can say f of x is defined for all the real values of x, just not when x is negative 5. But if you don't want to say this, you can write it in interval notation and say, well, it's defined for all values that come from negative infinity. Oh, it won't fit there. All the values of x from negative infinity up until negative 5, or from negative 5 all the way to infinity. Yes, it's easy if you know where is it undefined. All right? Now that you know where it is undefined, then it's easy to tell where is it defined. It's not really challenging this one, but I think it's worth doing. Now this is how it goes. You need to simplify this. We are given the square root of x plus square root 4x minus 4. And this is multiplied by square root x minus square root 4x minus 4. We just need to expand this. I think we've done something similar to this already, but I just figured I should remind you because I remember back in the day, they used to confuse me as well. Expressions of this kind. Okay. Firstly, we can see that these two things are completely different from each other. So it's like we are having the square root of x, which is multiplied by the square root of y. And we know that this is the same as square root xy. That is what we know. So we are going to try and apply this. In other words, the whole thing here becomes x and the whole thing there becomes y. So this means we will be having the big square root, but it's the square root of what? Well, in the first bracket, we're going to have x plus square root 4x minus 4. And I'm opening brackets because we now have two terms multiplying two other terms as well. This is what we say. So yes, this is what we will have. Then we realize something as we look at the terms within the big square root. We know that when you have x minus 4 times x plus 4, those are conjugates of one another. And if you must expand, you just need to multiply the first terms and the last terms together because, well, the middle terms will cancel out. It's the same thing here. The first terms are exactly the same and the last terms are exactly the same. But the sign in between, well, the signs are opposite. So this means we have conjugates of one another. And how do we deal with those conjugates? We multiply the first terms together. So x multiplied by x, we get x squared. Then we say minus the square root of 4x minus 4 multiplied by square root 4x minus 4. Well, the square roots will cancel out. We are just left with 4x minus 4. Step by step. And then what do we say? Well, now we can see that we just need to expand this. So we get x squared minus 4x plus 4 inside of the square root. And then we can factorize this and say factors of x squared are x and x. Factors of 4 that add up to 4 should be 2 and 2. And of course, this is the same as square root x minus 2. Oh, yes, they should be both negative. So here the square root and the square will cancel out, giving us x minus 2 as the answer. Just take it step by step and open your eyes as you are doing it. The aim is to simplify your mathematics. Try to have something simple for yourself. Okay. Now here they say we need to simplify without using a calculator. Now what is that which we need to simplify? In the numerator, we are given square root 7, but 7 is raised to the 2011. When I was in grade 3 on this year, 2011. Let's think. Yes, that was grade 3. I bet you are not born by that time. Now here they say we have square root 7 raised to the 2009. That was in grade 1. And this entire thing is divided by square root 7 raised to the 2008. That was in grade R. And I remember I was asking my grandfather a year before he registered me in school that when will you register me in school? Imagine. Yeah, not knowing what I was asking for myself. Okay, so then what do we say here? We need to simplify this without the use of a calculator. Now, what is the idea? The idea is to express everything in terms of the one that has the smallest exponent. That's the idea. The one that has the smallest exponent, which is 2008. Let us write this one in terms of 2008 as well as this one in terms of 2008 so that those with 2008 can cancel out. What am I saying? Let's go. This 2011, we can write it as 2008 plus what? Plus 3. Yes, that's what we can do. We just add 3 to it and we get the thing. So then we will be having 7 raised to the 2008 plus 3. Then we are going to reverse the first law of exponents and say before we added the exponents, we were once multiplying powers of the same basis. Do you get what I'm saying to you? When multiplying powers of the same basis, we add the exponents. But before we added the exponents, we once multiplied powers of the same basis. Very well. That is the first part of this. Then we move on to the second part. It's 2009, so we just need to write it as 2008 plus 1. So we have square root 2008 here, and this is multiplied by 7 to the power 1. You can choose to say 7 only, that's fine. Because anyway, any number has an exponent of 1. And of course, we still have square root 7 outside. And then we say this entire thing, what is it divided by? Well, let's see. Well, it's just divided by the innocent square root of 7 to the 2008. So this is what we are having. Then we are going to use the law of surds, the one that we just used in the previous question. So we take this to be x and we take that to be y. So we have square root x times y. And we are going to reverse it and say it will be square root x times square root y. Now, the 7 cubed, well, that's fine. We can still keep it that way for now. And then we say minus, we go to this one. Once again, square root x times square root y. And the whole thing is still divided by exactly the denominator as it is. And then here we still have square root 7. And the whole thing needs to be squared. It always goes down to basics. If your basics are good, yeah, that's good. Then what? Now we can take out a common factor in the numerator, which is square root 7 raised to the 2007. Why do we need to take it out? So that it can cancel out with the 1 in the denominator. That's the whole point. So let's do that. So now we take out square root 7 raised to the thing. And when we take it out, from the first term, we are left with 7 raised to the, well, square root 7 cubed. And 7 cubed is actually 343. And yeah, we can just write it as 343. And then from this one, we are just left with square root 7. And then everything is divided by square root 7 raised to the 2008. And then we can say this entire thing will just be further raised to the, oh, we still have an innocent square root 7 here. And the whole thing is still squared. Then these ones can gladly cancel out. And now we can say, what is square root 343? But if you go to your nice calculator and press square root that, you're simply going to get 7 square root 7. And then you will say minus square root 7, and you will add the long lost square root 7. And of course, you understand the whole thing needs to be squared at the end of the day. Now those ones, they will cancel out. And now we are left with 7 square root 7, which is squared. And of course, that will give you 343 once again. Well, that's what you say. Doing it step by step and remembering the basics was the best way out.